this 3 meters, it's pointing to this pole. Yeah, like that. It's like it's not. Are we just you're reading like this thing, this line, and so this is 2.5, and this is 3 meters. So it's
All right, ladies and gentlemen, I would like to get through as much of this before the announcements start as possible. So, please open to the sheet, because a lot of it you can do is doable in your head without too much explanation. Damn!
Seniors, these are your announcements for Friday, February 22nd. Grade 12 students are reminded that the deadline for the Big Abbotsford Foundation Scholarship and Bursary Program is Monday at 2:30. No late applications will be accepted. Please note that there have been some additions to the Abbey Senior checklist of available awards, and your 4 written statements are 1,000 characters, not words. Grad photo retake sign-up sheet is in the office. Retakes are going to be on Friday, March 1st, 2019, from 2:30 till 9 o'clock p.m.
Are you allowed to switch X and Y?
Library. Everyone is welcome. Senior rugby practice is cancelled today due to field closures. See you all Monday. Grad clothing sale has been extended to Sunday, February 24th at midnight. Rugby kits have arrived. Pick up an A106 at lunch or after school. Soccer intramural sign-up in the Rotunda today. You will need 5 to 8 players. We start on Monday, so come on down and sign your team up. Order forms for Krispy Kreme donuts are finally here. You can pick them up in the Rotunda today at lunch. You can purchase 1 dozen donuts for $15, or they're $1.50 each. We will be in the Rotunda every day at lunch to collect your forms. Please return them along with your payment by Friday, March 1st. Pickup will be March 13th. All proceeds will be donated to orphans in need. Come out and support your community. And remember, donuts are 100% fat-free in the center. Attention junior girls.
Slightly delivered better than yesterday.
For the pit for this Friday at lunch for your team photo. There will be a mandatory meeting for grads that signed up to participate or would like to participate in the grad cultural show today at the start of lunch in R204. There will be a JV football meeting for anyone who played JV football this year in room A203 at lunch today. Could the following students please see Mr. Peters in the Counseling Center today at lunch to pick up a Dogwood District Scholarship form? Macfrey Brar, Alicia Ellis, Keisha Hansen, Scarlett Hayward Mallet, Christina Lee, Parpuneet Man, Kat St. John, Amrit Kappa. Report cards are available in the office. Any girls interested in trying out for the senior girls soccer team? Tryouts for the senior girls soccer team will run on Tuesday, Wednesday, and Thursday next week on the turf field from 3 o'clock to 4:15. If you have any questions or concerns, please see Mr. Federley in A305. Tryouts are open to any players in grades 9 to 12. Could the following students please see Mrs. Chartrand in the office at lunch? Owen Ayala, Zar Alkma, Taylor Wagner, and Ashton Arn. Now we have a special guest announcement.
Good morning, Abbey Seniors. Our concert is coming up on March 6th in the Abbey Arts Theater. Today is the second last day for auditions on the stage in Pitt Gym. Monday, we will be having the final day for auditions in case you missed your audition or you didn't get a chance to sign up. Sign-ups for Monday will be in the Rotunda today at lunch. If you are auditioning, please ensure that you bring any materials needed. Bands can also bring in a video of them playing, if that is easier. When you come for your audition, please make sure to get down to the stage as soon as possible so we can begin. Stay tuned to the announcements on February 27th for our final act, as well as on our school's Instagram page for the final list. We cannot wait to see your amazing talent.
And the following students need to report to PAC today in room A209 at lunch. Simran Bola, Mia Bolton-Trent, Emily Campbell, Brianna Coronado, Amrit Dillon, Lydia Flores Salazar, Rajveer Gill, Michaela Godden, Siama Quote, Emily Lang, Zach Blankfield, Elena McCaskill, Jaden Mackey, Brooklyn Molina, Fidiomi Olabode, Gerline Rekar, Jiddu Saleh, Sage Schwab, and Noah Stuckless. Have a great day, Panthers. Now back to learning.
All right, we're back. Yeah? What? What did you just say?
Oh, nothing.
Okay. Ah!
I got
Number 6, I got 29%.
Wait.
I did too.
Well, then that's probably what it is.
I mean, like,
Oh, yeah. It's 29. Yeah. 0.6. All right. Everybody can Pythagoras, right? Whatever the point is, I don't care. Everybody can Pythagoras, yes?
yes.
What is the key? Always remember the hypotenuse has to be the longest side. If you have done work and it is not longer than the other two legs, you have done something wrong. Do not believe your calculator. Use your brain. It is smarter. Okay? Your calculator is simply the difference between a power saw and a hand saw. You could do all this math on paper with a pencil. It would just take longer. Everybody is good? Good. Now, please turn back to page 48. A lot of stuff we're going to do on page 48 you have already done. Well, you should have already done. But since I didn't show you it, I cannot be guaranteed that you have done it, so I want to make sure. Plus, there's going to be a lot of terminology from this page that you are going to need to know. Okay? Okay. Let's start then. 1, the first thing we need to know is we name triangles by their, that's the wrong there, idiot, their vertices. Vertices is the plural of vertex. Where is a vertex? Hazel? It is a corner of an angle. Okay? A vertex is the point at the corner of an angle, which you all already know. That's how we name them. And they are named using caps. So, what would you say is the name of this triangle? Eckham. ABC is a perfectly acceptable name for this top triangle. You could also name it CBA, you could also name it CAB, you could also name it CBA, ABC, BCA, thank you. Order does not matter until you bring another triangle to the party. Everybody cool? So that's how we name that guy, that's how we name that triangle. That's how we name all shapes. We always go by the corner. So if it's a pentagon, then it's going to have 5 letters in its name. Everybody cool? That big noise is Mr. Deweydoff blowing stuff up, from what I've been told. He was going to be blowing up sodium outside today. If you haven't seen sodium hit water, you're missing out. All right, everybody good? Easy peasy. All right, now, that's the triangles. Now, triangles have 3 angles, but they also have what? 3 sides. Good. Second point. I don't want to use black. I want to use purple. Second point. Sides are named, not named by their opposite. And what does opposite mean in this unit? No. That's what a hypotenuse is. What does opposite mean? Colin? Across the shape. They are named by their opposite vertex. And we using small letters. I should have said uppercase and lowercase, but I didn't. So, what then is the name of this orange side? It is what? Lil B. Because he's opposite from Big B. So what is the name of this red side? Lil A. What is the name of this blue side? Lil C. Aight? Now, my good friend Anu said AC for that side. Is that allowed? Yes. You will see some places labeling them by the vertices that connect them. I don't like to do that because it means writing more letters. And it doesn't allow me to reinforce that opposite means across. Aight? Aight. So this could also be CB or BC. Everybody cool? I will not do this. But some of your textbook questions that are in your book do. I use this. Is everybody cool? Yeah? Okay. Now, we are going to do a little bit of work with this. And you are going to do that work with this. Ta-da! What is the measurement of angle A? 30 degrees, right? What is the measure of angle F? 30 degrees. What is the measure of angle B? is so sad. 55. You guys should be intelligent young people. What would you guess is the measurement of angle E? No, angle E. 55. Now, without using the protractor, what is the measurement of angle C? 95. Why?
180.
Absolutely. That is the next point about triangles. The angles add to 180 degrees. All right? Now, because angle A equals angle F, and angle D equals angle, I should have done it the other way around. Angle C equals angle D, and angle B equals angle E. Because all those angles are the same, these are what we call similar triangles. Okay? You all should know that. Similar triangles share a property that allows us to build stuff. The reason that what we're about to do works is the reason we are able to have blueprints. It's the reason we are able to build IKEA couches. It is the reason that we are able to do trigonometry, because of what we're about to prove, which you all should already know. Now, down here, there's a bunch of white space. Why do I leave white space? For you to write stuff that is kind of separate but not really part of the lesson. Okay? That's what's going to happen down here. Angle F has another name. What is it? Right. It is angle DFE. Angle F has a third name. What is it? Angle what? EFD. What do you notice is common to all three names? The F is in the middle. The vertex is always there. Everybody cool? All right. Now, if I were to say that triangle ABC is similar, and that's what similar means, squiggly equal sign, to triangle, this bottom triangle, what would you name the bottom triangle? Right, FED. Why? Because when does order start to matter? When you bring another triangle to the party. So soon as I named ABC, I went from 30 to 55, 55 to 95, 95 home. So now, if I'm going to bring another triangle to this party that is similar, I must follow that same order. Everybody cool? This seems unimportant until you're dealing with like 6 triangles in one question, and you got to keep it together. Everybody good? Okay. Now, when you turn this page over to 48, 49. You see a chart. We've already done this on the front. We've done all that. What we haven't done are the lengths. So the lengths are on something we would have to measure. I don't want to bother every time I try to get 30 rulers. It's a giant pain. And then everybody argues about how many millimeters it is. It's 11.2 centimeters, Mr. Myers. It's 11.3 centimeters, dummy. It's 11.1 centimeters, idiot. So I've stopped in my 20 years of teaching, allowing you people to measure this for the sake of the lesson, because it takes 25 minutes for us to get 6 numbers. So I'm going to test you a little bit. Side EF is 14 centimeters. So put that in the appropriate box on page 49. Side EF is 14 centimeters. So you got to figure out how that works between the info I've given you and how you're going to fill in your chart. There is all of your info that you are supposed to get onto the chart on the next page. I will wait a moment for you to do so. Because, let's be honest, what's the skill here? Using a ruler or knowing how to convert between this and the other way of naming sides? That's what's important in the math class. Y'all learned to use a ruler when all y'all were in like grade 2. All right, so what number is going in to length of side A? 4.5. What number is going into the length of side B? 7.3. And what's going into C? 9. What's going into D? D. 14. What's going into E? 11.5. What's going into F? 7. Yeah? Now, please notice that A, side A, and side F are in the same position, yes? So, this is what is important here. A divided by F. 4.5 divided by 7. What is that? Use your calculator, obviously. What is it? 0.642, yes? So 0.64. What is BE? 7.3 divided by 11.5. What's that? It's 0.64. And what is C, 9 and 14? What's it going to be without even going to your calculator? 0.64. Of course, they aren't exact because it was measured on a computer screen with a piece of crap ruler. Everybody needs to know this is what makes us able to do all architecture. The fact that this is how shapes behave. If you take a shape and then you take another shape and you say this is an X, this is a Y, and this is a Z, I don't even want to use letters. That confuses the issue. If I give you this shape, star, dollar sign, and peace sign, and I tell you that down here we have peace sign, star, dollar sign, what can you automatically say about those two triangles? They are similar because they have the same angles, right? Once you know they are similar, if I tell you that this side is 14 and this side is 22 and this side is 7, you should be able to tell me how long that side is, how long that side is, and how long that side is. Because of what you just proved. How do we do that? We know that in similar triangles, if I take the same side and I divide it by the same position side, I get a fraction or a decimal, yes? And what were all those decimals? The same. So, if I compare two sides that are the same, any two sides with any other two sides, I'm going to get the same value, aren't I? So, on this drawing I have here, do I know the values of any two sides that are in the same position? What are they, Ken? Oh, I see what you're doing. You're giving me the actual answer. I just wanted the pair that you're using to prove that, because that answer is right.
Okay, so I use
7 and 14. If he takes star to dollar sign is 7. Son of a... And he compares it to star to dollar sign on the other one, he gets that, yes? Which means every other comparison has to be the same. So he knew peace sign to star was 22. So since 7, he used the numerator there, he's got to put 22 there. Then he goes over to here, star to peace sign is what he does not know. He gives it a variable, and he solves. Now this one is easy to do in your head because you know it's 1/2, so it had to be 44. But the way to solve it is you multiply the pair and you divide the spare. And you will get the answer. Always. Everybody cool? And once you know that for that one, you know that's 44. Now, can you tell me the third side? Is it possible to do? Right now, do you have the abilities? Not yet. Everybody cool? Why not? You know it has to be 7 over 14, has to equal 22 over 44. Why can't I do the third one? Absolutely not. It's not a right triangle because I didn't put the symbol in. And these, green and yellow, are both unknown, aren't they? So I would have x over y, and you cannot solve that. Everybody good? Everybody remember similar triangles? Everybody did some of this in grade 9, I hope? No? You didn't do scales in grade 9 either? Like if I'm 6 feet tall and I'm standing beside a tree and you take a picture of the tree and I ask you and me by the tree and I ask you how tall is the tree, you guys didn't do that? Okay. We'll fix that as we come to it. Okay, well, hold up then. Hold up. Did any of you do any amount of trigonometry? Where were you? That you're the only one that did trig. Okay. Well, everybody should have been.
Were you in Mr. Lineover's class?
Okay, guys, ladies, gentlemen, and everything else. I cannot hear more than one of you at a time. How many of you did some trigonometry in the 9th grade? I see. Okay. So you 6 are going to be very bored for the first little while. The rest of you, you're going to want to pay very close attention. Now, you should have done some. So, when I go to the next page, I am starting, listen please. Listen please. This is only a half page of notes. There's a big, huge thing that goes before this that I use to introduce trig. But I don't do it in pre-dip 10 because most of you usually should have done it. So, I'm going to take a moment to give you a truncated version of that introduction. Okay? You don't need to write it down. You just got to look. Hit the top left button, please. Thank you. Somebody from the back, throw me up a couple of markers. I need different colors. Don't throw it to me when I'm not looking, because if you hit me in the back of the head, I'll be pissed. 1, 2. Aye. please notice that I have drawn two triangles, yes? The first triangle is triangle BAC. Everybody cool with that? BAC, yes? All right. A to C, 19. A to C is 40 centimeters. Cool? B to C is 30 centimeters. Everybody cool? Automatically, how long's AB? 50. Cool. But that's not important for today. Angle A is right there. Yes? Everyone agrees? Okay. Now, if I asked you, because these are similar triangles, all the fractions are going to be equal, right? Okay. What would you call that side? You can give it one of three names. Lil A. What else? BC. What else? CB. And that side is what compared to angle A? Opposite. How do you know it's opposite? Because it's a cross. Excellent. This side right here is the only other side that we know right now. Now, we all know that the other side's 50 because we can do Pythagoras in our head. But let's pretend we didn't. This is the other side we know, correct? So what is the only fraction I can make right now if I want to compare anything? Make me a fraction. Compare two sides of this triangle. Make me a ratio that compares two sides of this triangle. So, 30 over 40. Thank you. 30 over 40. Everybody cool? All right. Now, that is also 3/4, yes? It is also 0.75. Everyone agree? Okay. Now, this whole distance here is 80 centimeters. Everybody cool? This whole distance here is 60 centimeters. Everybody cool? What is the only thing that is the same in both triangles? Not similar, the same. Angle A is the same in both, yes? Okay. So since angle A lives in both of these, now in the pink triangle, can you give me a ratio? What would it be? 60 over 80, which would be 6 over 8, which would be 3/4, which would be 0.75. Everybody cool? Now, knowing what you know from just that, if I drew this blue line from A to D all the way up to the roof, and I drew this line AF all the way over to the wall, and then I measured from the wall up to where it made the triangle, what would the ratio be? 0.75. No matter what. Because no matter how tiny I make this, the triangle, this has stayed the same. If I put this line right here, and I said this was X and this was Y, what would you know about X over Y? It would be what? 0.75. Or it would be this fraction. Is everybody cool? That's trig. If you understand that, you can do the whole unit already. Everybody good? Because all trig does is compare angles to sides in a triangle. Yeah? Okay. We got lots of time. Top left button. Excellent. Now we are going to do the most frustrating thing in my entire math existence. Everybody pick up your calculator. When I say your calculator, I mean your calculator. If you still don't have one, in my head, I am mocking you mercilessly. But out loud, I am just saying, please, class, go get yourself an actual calculator that is not your phone. Okay? My internal voice was significantly different. You can fill in that blank with your own imagination. Aye? Everybody's looking at their calculator now, yes? On your calculator, on its gray screen, please look and see if you can see one of the following things. You are looking for either a little d, well, a capital D, but it's physically small, or D-E-G. If you have a G or G-R-A-D or an R or R-A-D, please put up your hand if you have one of these two. If your calculator screen looks like this, with a D or DEG, you are okay. I haven't turned it back on. Down. If your calculator looks like this, it has D or DEG, do not put your hand up. If you have G and grad or R and rad, put your hand up. Okay. No. That isn't what I asked. Please, this is confusing and a giant pain in the ass. So listen to me. Do not speak unless you need to for the next couple of moments. If you have G and grad or R and rad, look on your calculator somewhere for a button that has D, R, G, and it might have an arrow beside it. Push that button until your calculator says D or DEG. If you cannot find that button, put your hand up. Well, you have your phone. That is a giant pain in the ass, as I said. Get a calculator. Everybody else is good? Everybody else has DEG showing? Again, it can be a D or DEG. Now, this is where I prove how many, or I find out how many of you can figure this out. Listen to me carefully. I will show you visually. On your calculator, all of you should have buttons that say sin, cos, and tan. Right now, looking at a blank calculator screen, push the button that says tan. If your calculator writes the word tan, you have, there's a technical name for it, but I am not going to name it. You have what I call a forward calculator. So, if your calculator writes tan, and it often starts with a bracket, you have what I call a forward calculator. You punch in what you see. If your calculator does not write the word tan, you have what I call a backwards calculator, and you must reverse the next instructions. Okay? Everybody with a forward calculator, push the button, tan, then push 3, then push 5, then push equals. If you have a forward calculator. If you have a backwards calculator, you push 3, 5, 10. And you do not need to hit equals. And then your calculator should show, if you are in the right mode, which is degree or D, your calculator will show 0.700 and a bunch more numbers. Does everybody's calculator show that now? Good. Whose responsibility is it to know how your calculator works? Yours. Should I and you be wasting your classmates' time continually asking how to work your calculator? No, it is your job to learn. There's only 2 ways it can be. Tan 35 or 35 tan. You got a fitty shot. Everybody good? Okay. Now, all of you tell me now what the tan of 15 is. And I like 3 decimal places. We are on page 52. What is it? Jaden. I know you're Jordan. That's why I didn't say Jordan. Jaden's over there not punching any buttons. You did. Oh, I didn't see you punch any buttons. I saw him punch buttons. Oh, I see. So what is it? Excellent. 0.267. And what is 45? 1. All right. Now, this is a real problem for my students. You guys aren't so hot at what I'm about to show you. Turn this into a fraction. It's not. What is it, Hazel? 7 over 10. Because it's 700 over 1,000. Turn this into a fraction. 267 over 1,000. Turn this into a fraction. 1 over 1. Everybody cool? Now, you know from my demonstration on the board that if I draw a triangle and I say this is the angle I care about, the ratio we have just found is this side, which was opposite, over this side, which has a name, and if you haven't done trig yet, I don't want to name that yet. There's a reason. It's this ratio, yes? Okay. Knowing what you know now, what number would I write here if this was 35? What number would go there? 7. What number would go there? 10. If this was 15, what number would go here? 267. And what number would go here? 1,000. What if I made this triangle? I told you this triangle was only 100 long. What number would go here? 26.7. It's a 7. Everybody with me? What if I told you this number here was 10? 2.67. Everybody cool? Okay. What if I told you this was 45? What number would go here? What would go here? What if I told you this side was 33? What number would go here? 33. Right? Because if this is 45 and this is 90, then this is 45. And if they would have to both be the same. Is everybody cool? All right. That's trig in a nutshell. Everything else comes from that point. Everyone is good? All right. Now, please notice that our calculator will give us the numbers to create the actual triangle, right? Well, it will also reverse that. And you reverse that by using, again, a button on your calculator. Please notice, the tangent of an angle gave me a fraction, yes? It didn't give me the angle, it gave me a fraction. Well, what do I have here? Do I have an angle or do I have a fraction? I have a fraction. How can I construct a triangle from that fraction? I need an angle, don't I? So that angle we get on our calculator by using this function, tan -1. If you look carefully on your calculator, you will see printed on the actual calculator right above the tan button, tan -1. How do you access those functions? You use second function or shift on your calculator. On whose calculator? Your calculator. My calculator has second function. Yours might not. Whose job is it to know how your calculator works? Yours. Now, if it happens once in math, it always happens in math. So if you have a forward calculator and you push tan 35, what do you think you need to push here? You need to push shift, or whatever your calculator is, tan, and then 0.75. And that will give you an angle. If you have a backwards calculator, what do you think you do? 0.75, shift, tan. And you will not need did equals, but in a forward calculator you will. Now, tell me how big that angle is. 36.8 degrees, yes? Now, this is a 0.75, isn't it? Right? 30, 40, 4.75, yes? Which means, how big should angle A be? 36.8, right? Come to the front, Jesse. My lovely assistant, Jesse Davis, ladies and gentlemen. Give him a hand. What is the angle? Oops, I'm getting twitchy because I'm old. Roughly 36, no matter about the size. Everybody understand? If I draw a triangle this big and I do the trig with it, I can then build that triangle because the angles will stay the same. Everybody good? Spectacular. Now, what is weird about question B? It's a negative. When you punch that into your calculator, what value do you get? What is it? What is the angle that goes with that? Pardon me? Negative 50.8. So, why is that weird? A negative angle doesn't seem to make sense, does it? We're going to spend a lot of time with this later, because up until this point, you have only been dealing with angles in one part of that. That is X and Y. Please notice there are 4 parts, yes? You have only been dealing with angles up to 90, haven't you? Well, how many angles are in that? 360. So you will be dealing with negative angles. Negative angles go this way. So I would go down 50.8 degrees. which means it is also, how far is that? 310, right? Because I went down 50. So I went around to 310. Now look. Tan negative 50.8. Oops. I meant to go the other way around. Tan 309.2. Negative 1.23. Everybody see? Not too important, just giving you a warning that we will be going further than 90 degrees in this class. And lastly, this one's easy. What's the angle here? Because it's positive. 16 degrees. Everyone cool? That's trig. Now, for any specific, when I say specific, I mean it has to be the acute angles. What does acute mean? Smaller than 90. This only works for smaller than 90s. The tangent ratio compares the two legs. So what side is never part of tangent? The hypotenuse. It only compares the legs. And the legs it compares are always the opposite leg, which we already knew, divided by the other leg. Now it's going to get a name. Opposite, the third side of a triangle is hypotenuse. The last side is the adjacent side. The adjacent side is simply the leg that is not opposite or hypotenuse. Now, a lot of people have trouble with that. You don't have to write this down. I'm just going to draw it right here. If that's A, where is the opposite side? Is it the vertical one or the horizontal one? Vertical one. That's opposite. Right? This side we know is the hypotenuse, yes? So the only leg left is here. That's the adjacent, because it doesn't have a name yet. Everybody cool? All right. Now, let's actually put this into practice. Here is a triangle. I want the tangent ratio of A. A ratio is a fraction, yes? The tangent ratio is always opposite over adjacent. So where is angle A in this example? Top or right? Top. Here is angle A. I want the tangent ratio, which is opposite over adjacent. How do I find the opposite? I go across the shape. And what number do I hit, Hazel? 12. Then I need the adjacent. What's the adjacent? 5. Because it's the leg that isn't opposite and isn't hypotenuse. I don't like to say it's the one beside, because then somebody invariably picks the hypotenuse, because the hypotenuse is also beside A. What happens if I move to angle B? Is it still opposite over adjacent? Yes, but I am no longer here at A, am I? Where am I now? I wish I was that skinny. Woo! Now I'm down here. Now what's opposite? 5 And what's adjacent? 12. Does everybody see how it works? Great. Now, how are you going to tell me what the angles are? Is angles tan or shift tan? Angles are tan. What are sides? Shift tan. Go. What is the angle of A? And what is the angle of B? Wait a minute. What did you guys just say? Angles are tan and sides are...
Shift tan.
Look at what we just did. Everybody usually gets that, so I just kept repeating. If I know the angle, what do I hit? Tan. If I don't know the angle, what do I hit? Shift tan. What do I need here? I need shift tan because I don't know the angle. Some of you will know how to find these angles right now. Some of you are going to be confuzzled. That's okay. What's angle A? Who knows? $67. And yes, we usually round angles off to the nearest number. What is B? 23. Now listen, please. Almost all you aren't going to do what I'm about to ask you to do, and it's going to make me angry in a couple of days when you ask me, how'd you get that? When I put a number on the board. And I'm going to say, did you write what you're supposed to do on page 52? And you're going to say, yeah. Then I'm going to say, well, then why are you asking? Or you're going to say, no, I didn't, Mr. Myers. And then my internal mocky voice is going to be going, but I'm going to say, maybe you should turn back to page 52 and do that. Avoid that by doing it now. Write what you had to type into your calculator to find these numbers. I had to go on my machine, second, tan, bracket, 12 divided by 5, bracket equals. That's what I had to do. To find B, I had to go second, tan, bracket, 5 divided by 12 equals. That's what I punched in. You write what you need to punch in. And the only thing that is going to change is whether you hit sine, cos, or tan. Right now, we're only working with tan. Everybody cool? Now, since we are only working with tan, are you ever able to use that tan button to find the length of a hypotenuse? No. You can only find a hypotenuse right now if you know both sides. So if you use tan to find both of these, how are you going to find that? Colin? You'll use Pythagoras. If you've already done trig, you know how to use sine and cos, and you could find the hypotenuse that way. But some of you don't. So you are going to be doing Pythagoras. Everybody good? All right. Now, let's see if we can do this a little bit. Everybody turn over to page 53. and I'm going to show you a foolproof way to do every trig question. If you do what I am going to do here, you will never, ever, ever, ever get a trig question wrong. All right? Here is what you do. First thing, no, you won't, Brant, trust me. There's a bit of blank space here. Why? Because that's where I write the stuff that isn't math, but that you need to know. And this is the important thing. In geometry and trigonometry, because it was not really invented by, but we say it was invented by the Greek mathematicians. It wasn't really. It was being discovered at the same time in Egypt, in India, in China, in Persia, all over the place. But because we are Eurocentric, we use Greek stuff. It's not right, but that's what we do. We use this symbol. It is like an O with a line through it. It is the Greek letter T, and it means theta. Theta is just some angle about which you care in a question. Okay? So if there's an angle that you know and you're trying to find sides, or there's an angle that you don't know and you have the sides, that angle is called theta. Everybody cool? All right. It just means some angle. All right? Okay. So, if you do what I'm about to do, you are always going to get every trig question right. Here is a triangle. Is there an angle there that I care about? Yes. So is there a theta? So I write theta equals what? What is theta right now? No. It's x. Everybody cool? Okay. Once we establish that x is our theta, that means that is where we stand to look at the triangle. That's me. Everybody with me? Which means if I am standing here, what is 23? Opposite equals 23. What is 15? My adjacent. Now, I know that tan theta equals O over A, right? Tan of any angle is opposite over adjacent, right? Now, I'm trying to find that angle, so am I going to be using tan or shift tan? Shift tan. So shift tan of theta also equals O over A. Can I fill this in now? What would I put for theta? Shift tan of x equals, what do I put for O? 23, and what do I put for A? 15. And then I just punch it into my calculator, exactly like what we did on page 52. What's the value of x? What? 37 degrees. 57. Okay. Everybody good? All right. Let's try the second triangle. Is there a theta, an angle about which we care? What is it? It is angle F. Can I put a value there? Theta equals 15. Which means that is where I am standing. So what is that? Opposite. And what value does it have? X. And what is 37 then? Adjacent equals 37. What do I know? I know that tan theta equals O over A. You guys are seeing everything disappear, right? Okay. I'm just going to do this because it's pissing me off. It's not even going to let me close it. Fine, be that way. I'll show you. Yeah, boy. So, can I fill this in now? Tan of what? 15 equals what? X over 37. Now, hey, wait a minute. Mr. Myers did that thing a couple of days ago where he said, if there's a number on the bottom of an equation, what do? Multiply. So X equals 37 times tan 15. If you have a forward calculator, what are you going to punch in? You're going to punch in 37. You might not even need to push times. Some of the calculators will do it automatically. You might be able to go 3, 7, tan, 1, 5 equals. If you have a backwards calculator, what do you got to punch in? 15 tan times 37 equals. And what do you get? What? 10? It's a value. It's not an angle. So are we going to round it off? What should we put it in as? How many decimals? 1 at least. So what is it? 9.9. Now, everybody is good? Okay, let's try it one more time, then you're going to do it by yourself. Over here, do I have a theta? What is it? 70, which means where am I looking at this triangle from? Right there. So what is 14? Opposite is 14. What is adjacent? X. What is tan theta always equal? O over A. Can I fill in some of this now? Tan of what? 70 equals what? 14 over X. What do? Division. X equals 14 divided by tan 70. You need to know how to work your machine. What's the answer? What is it? 5.1. Can everybody do tangent? Now, is there any way to make it more complicated? It's either find the angle, because you know both sides, find one side by multiplying, or find one side by dividing. Everybody cool? Great. See if you really can. Let's do this side. Go. Work with your neighbor if you need to. It's a little tricky because all of a sudden I'm asking you to do one more step, aren't I? Remember, how do you do it so you can never make a mistake? When you have a value, don't shout it out loud. Just leave it on your calculator. Do not push clear. Once you have this value, which will be a bunch of decimals, leave it on your machine. Does everybody have a bunch of decimals on their machine yet? Does everybody have 13.85640646? Excellent. Now, stop for a second. Is the question finished? No. But, are we going to write that old big number here? No. What are we going to write here? What are we going to write? 13.9 is fine. But we're going to leave that number there because I know I need it again, don't I? So I'm going to write 13.9 here, but I'm going to leave that there. How am I going to find y? It's going to be 13.9 squared, 24 squared, and then what am I going to do to that answer? Square root. Right? It's sitting right there, isn't it? So if I go, this is a very powerful tool on your calculator that many of you may not be using. I recommend you start. Watch. Square root. I need this number here, right? On my calculator, second, see this ANS key? Stands for answer. Your calculator holds the last number that you got by pushing equals in its memory. This was the last number I got, right? So if I go answer squared, I have the whole decimal already there for me. Then I add 24 squared, and I hit equals. And I get an answer. The ANS key is very, very useful to you because it means you don't have to worry about rounding in the middle of a question, which will give you a better answer. Everybody with me? Do you have to use it? No, watch. If I do the square root of 13.9 squared, which is what I rounded it off to, right? Plus 24 squared, I get 27.73. Does that matter in math class? 27.7 or 27.7, right? Does it matter in the real world? Depends on what you're doing. I said you would have no weekend homework. I am a bit of a liar. You're only going to do 3 questions. Just those 3 triangles. And you might notice they're exactly the same as the 3 I worked with you on, except the numbers are different. Take the next 2 days off, except for 3 questions.